So we'll continue with FT. So there is one cluster with multiple VMs. Inside each host, there are some virtual machines are running. So FT is a VM level feature. So normally, if something goes bad with entire host, what will happen if host goes down suddenly? What will happen to the VMs? Move, but how? How they will migrate? vMotion, cold migration, or anything else? Which feature will work? If a host suddenly fails, HA what it will do? So vMotion is wrong answer. vMotion is live migration when the VM is power on itself, moving from one host to another host. But this is, I'm saying, sudden failure, unexpected failure. When the server is shut down, immediately the VMs also will power off on that host. We will not have enough time to vMotion. So vMotion is completely wrong. Okay, not acceptable. So VMs will restart on another host. By which feature? HA. If you enable HA, if a host fails, all the virtual machines will automatically restart on another host. Okay, we have to just say restart on another host. Right? But if that entire host fails, what if there is a problem with one virtual machine, but this virtual machine is critical for a business, the organization, whatever the application they are running here on that virtual machine, it's critical for them, but something problem is there. Until you fix that problem, guest OS problem or VM level problem, it will not come up on the second host. Okay, even with HA, its entire host failure will work. Until you fix this problem, the applications will not come up. Okay. So to handle these kind of situations, there is a feature called FT. Once you enable FT, let's say this is a VM level feature, and let's say if you enable FT here, and it will become primary VM, and automatically another secondary virtual machine will be created with exactly same name. In the bracket, you will see it as secondary. The virtual machine name next to it, it will be primary written in primary. So something like this. Okay, so if you see, it will be like this. Once we enable, it will be like this. VM primary, another virtual machine with the same name, VMW, secondary will be there. But that will be automatically created on the another host. In the cluster, if there are three hosts, it will be created automatically on any one of the hosts. Okay, secondary virtual machine. Now, if something happens to the primary VM, automatically the secondary VM will become primary. That means applications will continue to function from this secondary virtual machine, this virtual machine now. Okay. And here, during this process, once you enable FT, it's called primary and this called secondary, and there will be continuous replication between primary and secondary. Whatever the change, read and write operations that you are performing on primary VM, V1, will be automatically replicated to the secondary VM in the storage end. Okay. Everything that you read and write on this virtual machine will be whatever you write on it, not reads, only write operations will be automatically replicated to the secondary virtual machine. Okay. That means this machine, anytime if you see, this machine will have latest information about primary virtual machine. And there will be continuous heartbeat between ESXi1 and VM1 primary machine and the secondary machine via the ESXi VM kernel port group. The heartbeat between primary machine and secondary machine will be happening over management network, VM kernel port group. Okay. Now, in case of any problems on the primary machine, less than 2 milliseconds, very, very negligible amount of time, less than 2 milliseconds. Takeover will happen. If there is any problem, less than 2 milliseconds, secondary machine will become primary. Whatever the application that are running from primary will continue to function from the new primary now. So in this case, there will be no outage to the application functionality. Even though there is a problem on the virtual machine, there will be no application level outage. Okay. Customer will not face any problems with respect to application. Clear? So this is VM level feature. We enable on individual VM. Once you enable, secondary VM will be created. Whatever the write operations that are performed here on the primary machine will be automatically replicated to the secondary VM. And in case of any problem on primary VM, less than 2 milliseconds, secondary will become primary and applications will continue to function from here. You don't need to fix this problem. Automatically, another secondary will be created on the third host. That's why 3 hosts are mandatory for FT. Another new secondary will be created here. Once it becomes primary, automatically it will become secondary here. Now the primary to secondary replication, it will be happening here. Same thing, if there is a problem, it will become primary. Fine. So it's important for interview point of view. Day-to-day job, you will not have anything to do with it. So it's not used. The minimum requirements to enable FT. Enterprise plus license. Top level license we need to have in the vCenter. Pick provision. Eager zero disk. HA is mandatory. And maximum 4 VMs per host you can save. Max 4 VMs per host we can protect with FT. We cannot, if there are 20 VMs, we cannot enable FT and all the 20 VMs. Per ESXi, we can protect maximum 4 VMs. It's not possible to protect all the VMs. So it's a VM level feature, no outage to the application. Fine. If something breaks in the primary virtual machine, secondary VM will automatically become primary and take over the application responsibility. So, and this takeover will happen in less than 2 milliseconds. So, no downtime for the application. And whatever the write operations that you are performing on primary VM, normally, whatever you write something on a virtual machine, it will be in the same virtual machine. It will not copy to any other VM. In this case, whatever the write operations performed on the primary VM will be automatically replicated to the secondary VM. So this technology is called VLOG step technology. So very important, FT works on VLOG step technology. All the write operations performed on the primary VM will be automatically replicated to the secondary VM. It's called VLOG step technology. FT works based on VLOG step technology. But the point is very important. They will be asking what is the technology behind FT. So VLOG step technology. So what is it? So all the write operations performed on the primary will be automatically replicated to the secondary. So if you want to enable FT, just right click on the VM. FT, turn on FT. So any questions from FT? So it's a VM level feature. HA is a cluster level feature. FT is a VM level feature. If you feel that it's critical for your business organization, we can recommend FT. To enable FT, there are some limitations or minimum requirements. These are the requirements for FT. Okay. And here, a very important one, CPU thing is very important. VM with 8 vCPUs only can protect with FT. 6.7 or later versions. Earlier versions, it was 4 vCPUs only. 4 vCPUs, 6.0 and 6.5. 1 vCPU before 5.5. Earlier versions. So if you see 6.0 and 6.5, if a virtual machine is there, if it has 4 vCPUs only, we can protect with FT. If it is more than 4 vCPUs, we cannot protect. If you try to enable FT, it will fail. From 6.7 onwards, 8 vCPU also we can protect with FT. If a virtual machine has 8 CPUs, still we can protect FT 6.7 and 7.0. Okay. Even before versions, there is a limitation. And once you enable, right click on the virtual machine. VM, right click on it, FT, turn on FT. Once you enable, it will become primary VM. Automatically another secondary will be created and there will be continuous replication between primary and secondary. Whatever it happens on the primary machine, everything will be replicated to the secondary machine. If something happens on this primary VM, immediately this secondary will become primary and a new secondary will be created and everything will continue to function from this location. So it happens in less than 2 milliseconds. That's why there will be no outage to the application. That will be continue to function. The application which is running inside this machine will be working as usual. Fine. So it's important for interview point of view and day-to-day job. There will be nothing to work with FT. Any question? Yes, whatever the data that is written on primary machine, it will be copied to the secondary. So it has 2 copies. Yeah, FT is like VM level feature, right? So if your host is fine also, when a VM is having some problem, then only it will create secondary once you enable FT. It's a different, on a different host it will create. It will not create on the same host. Secondary VM always will be created on the another host. On the same host, it will never create. That's why it need minimum 3 hosts for FT. It will never create on the same host. Because another, if your primary fails, another secondary should be created. So for that, the third host is needed. Fine. Just for interview point of view. And very common interview question, difference between HA, DRS, FT, and V motion. So they may ask any difference, like what is the difference between HA and DRS, HA and FT, HA and V motion. So by now, you know all the all the 4 features. Okay. It's a reactive feature. HA is reactive, DRS is proactive, downtime will be there as the VMs will restart. No downtime for the VM. There will be V motion. V motion is live migration, so there will be no downtime. Here also, no downtime for the VMs. The secondary will take over less than 2 milliseconds. Okay, so, and this is a live migration. We know that it's a live migration. DRS completely depends on V motion. And third one, no dependency on vCenter. VC must be available. And here there is no dependency on vCenter. That means even without vCenter also, FT will work and HA also will work and FT also will work. Even if vCenter is not available, HA will work and FT will work. We'll see the reason why. And DRS will not work. vCenter must be available. And vMotion also. vCenter must be available. vCenter, it's a vCenter level feature. We'll see that also, like if vCenter is not available, which feature will work, which feature will not work. Fine. Reactive. So that means, we'll just see here. Very important. So the difference between HA and FT and HA versus DRS. Any interview, you will face a question from this differences. They're connected like this. Okay, so we have a cluster here. Both HA and DRS features are enabled on the cluster. Okay, cluster level. If a host fails, we'll see HA. If a host fails, all the VMs will power off automatically here and they will automatically power on here. So we understood the entire logic, how it happens from the time of enabling HA until if a host fails, where it will identify the failure, what heartbeats it will use. The logic we already understood. Now, if you see that logic, once you enable HA, the FDM agent and the host will be trying heartbeat over management network. And second one, what is the second heartbeat it will use? Data store heartbeat towards the storage communication, whether both are connected to the same storage or not, and management network connectivity over network. So in this case, there is no dependency on vCenter. The failure detection mechanism in HA is working over network connectivity and storage connectivity. Okay, so there is no dependency on the vCenter. Even if vCenter is not available, it will work. Okay, because the failure detection happening over network and storage. So even without vCenter, it will continue to function. So that's why HA will work without vCenter also. Okay, vCenter dependency is not there. Next thing, it's a reactive. That means when HA is working, when there is a problem, to recover from this problem, it is powering on these virtual machines automatically on the second host. That means after a failure, it is working to recover from a failure. That's a reactive. After a problem, it is trying to help to recover quickly. Fine. And DRS is proactive. That means it will be continuously monitoring the host usage. If there is a RAM usage is very high on one of the hosts, another host it is less, it will try to vMotion the VMs from highly utilized host to the less utilized host. So that means it is working to avoid performance issues, to avoid the issues before the issue itself. Okay, proactive. Before something goes bad, it is trying to fix it. Fine. That's a proactive thing. Proactive and reactive meaning is the same. Then downtime will be there. That means VMs are restarting. Here they will power off and here they are powering on automatically. So that means there is definite amount of downtime will be there. That means business applications will be down. Fine. And in DRS, there is no downtime. So if a host utilization is high, it is trying to live migrate. When the VM is running itself, applications are working itself, it is moving from one host to another host. Even we are using Teachment now, the virtual machine which is running, and the website where what we are using, right, Teachment, it may be running on one of the virtual machine. It might have moved many times here and there. We are not interrupted. We are still continue to discuss. So that's what the downtime. So there is no downtime here. If Teachment suddenly shut down and it comes after 5 minutes, there is a downtime. We are interrupted. The application functionality is interrupted. Okay. Now, in advance itself, when we feel that VM creation is fine, application is running fine, and we want to protect it before something goes bad. That means on a healthy virtual machine, we have to enable it. After a failure, if we can't even enable, even if you enable FT, it's of no use. In advance, we have to. When it is healthy, we have to enable. It will protect from a failure. Fine. So DRS is live migration. Application will be continue to function. So no downtime here. That is the main difference between HA and DRS. Downtime is the difference. In HA there will be downtime for the VMs. In DRS there will be no downtime for the VMs because it uses vMotion, live migration. Okay. And FT also no downtime. When the primary machine, if there is any problem, less than 2 milliseconds, secondary is taking over the functionality. Fine. So there will be no downtime in FT also. In both the cases, HA and FT, there is no dependency on the vCenter because the failure detection mechanism happens over network and storage heartbeat for HA, and for FT, it happens only over network. So no dependency on vCenter. DRS, it is mandatory. Why? Because once you enable DRS configuration file will be created here. If you see the DRS feature, DRS configuration file will be created in the vCenter database. Okay, and this configuration file will be collecting the RAM and CPU usage of the host. Continuously, it will be collecting the what is memory utilization here, CPU utilization here. Then compare that if it is too high, try to vMotion. If vCenter is not available, this configuration algorithm, cannot find what is happening here. It will not be able to collect the data because it is down, right? It will not collect the data and it cannot suggest any migration. So DRS will not work. That should be your clear explanation when someone asks about the difference. Why HA will work if a vCenter is not available and how come DRS won't work. Okay. So the HA failure detection mechanism happens over management network and data store heartbeat. In DRS, the configuration file from the vCenter cannot collect the performance metrics and cannot execute any recommendations because if it's down, it's not accessible, right? In FT, again same, it will happen over management network, no dependency on the vCenter. vMotion is also again vCenter level feature. Without vCenter, we cannot use vMotion. Okay, live migration of VM. This is important for interview point of view and just for your knowledge also. Any questions here? Fine. Okay. If vCenter is not available, which feature will work, which feature will not work? We'll list them. J, DRS. This is also common interview question. HA will work, DRS will not work, FT will work, vMotion will not work, DvSwitch also will not work, snapshot will work. DvSwitch management will not work, but no impact to the host and VM network functionality. We'll see while discussing about the DvSwitch. We'll discuss about this. What is DvSwitch and snapshot also we have not discussed. If vCenter is not available, these are the features will work, and which are not work will not work. Very important for interview point of view. And we understood the reason as well why HA will work, DRS will not work, FT will work, vMotion. And these two things we have to discuss it. Okay. DvSwitch and snapshot. Fine. Okay, so next we'll see DvSwitch. It's called distributed virtual switch or virtual distributed switch. The common switch. Okay, we'll see how its architecture is. So this part already we have discussed, VSS, virtual standard switch. or standard virtual switch. Standard virtual switch or virtual standard switch. So every ESXi machine will be connected to two network switches for redundancy from the two network adapters. And here we will create a virtual switch. And it will be connected here like this. This is standard switch. Okay. And we create a port group on top of the virtual switch for communication. So we'll use these tunnels to send and receive the traffic. Now here the requirement or the question is, okay, there is one ESXi host. You created 50 port groups. You have to create same 50 port groups on the second host as well. The name of the port group, spelling, spaces, everything should be exactly same as on the first ESXi host. Okay, whatever it is created on the ESXi one, it should be exactly the same on the second one as well. If there is any mistake, there will be a few impact in the future. Any one of the virtual machine which is connected to, let's say, one of the network name created as capital prod, and the second host which is created as all small letters prod. Okay, production. The virtual machine was connected to this prod network. When you try to vMotion to another host, VM will lose network connection because the network is wrongly named here. It will not be able to identify the same network here, so VM will lose network connection. Okay, so like this kind of impact will be there in the future. That's why we have to make sure exactly the same 50 port groups are created. What if there are 20 hosts in the cluster? 20 into 50 port groups you have to create. 1000 port groups with consistent information. That means without mistakes you have to create. Even if was one mistake, there will be impact in the future. Okay. There is a possibility for human error, and also it is time taking process to create these many networks. To avoid these human errors and time to reduce this configuration, VMware has developed something called common virtual switch called as the DvSwitch. Okay, it is called DvSwitch or VDS, DVS or VDS, distributed virtual switch or virtual distributed switch. Okay. Here also the physical connections will be exactly the same. However, ESXi 1 and 2 are connected in terms of standard switch. Here also it is connected exactly the same, directly from the ESXi network adapter to the network switches. But their traffic flow will be controlled by uplinks on the DvSwitch. So there will be no switches on the host side, no port groups. Okay. So we will logically connect this network interface card to the uplink on the DvSwitch. This is a logical connection. That's why I'm giving dotted connection here. This is logical. Only in the vCenter it will be controlled. So now the same 50 port groups we create now on a virtual distributed switch here. These are called virtual port groups. Instead of normal port groups, we create DV port groups here. Instead of creating these port, now here individually we created on every host. Here 50, here 50, on all the ESXi hosts you have to create 50 port groups. Here the same 50 port groups are created here. These are called DV port groups. And these are called uplinks. Nothing but logical connections. Now, whatever the packet that comes from network, okay, it will come here, and DvSwitch will control whether to allow this communication inside or not. and once the packet will be decided by the DvSwitch, DV port group, it will confirm whether to enter host or not. Then it will enter and it reach the whatever the virtual machine that is running here. So the traffic flow, even if it comes directly here, it will be controlled by the common virtual switch. There will be nothing on the ESXi host side. If you see in the older network here, if you send any packet, it will enter here and every host has a virtual switch. This is a standard switch. Here it will control to enter inside the host or not. Here, DvSwitch common switch will decide to enter or not. So whatever the 50 port groups that we created here on top of the DvSwitch, here we created, right? It will be same, visible, exactly same as to the second host as well. Because this host is also connected to the same DvSwitch, whatever port groups we created, it will be exactly visible the same way how it is visible to host 1, host 2 also it will be visible the same way. If you create capital prod, it will be visible to all the hosts in the same manner. So that means we can avoid human errors in configuration. That's what compliance. Compliance means everything should be exactly same. Everything is in respect to networks here. Okay, so we can avoid human errors. And also, if you create 50 port groups, DV port groups is enough here. All the 50 will be visible to all the ESXi hosts, 20 ESXi hosts or 10, whatever it may be. You don't need, you just create 50 port groups. They will be visible to the all the hosts which are connected to the DvSwitch. Fine. So you don't need to create 1000 port groups and you only need to manually verify whether they are consistent or not, whether they are same, exactly same or not. You don't need to worry about that. However you create, it will be visible to the same way. So we can avoid human errors and time to reduce the configuration of network configurations. 50 port group is enough. You don't need to create 1000. Okay. That is the advantage of this common switch. Very, very important for interview. Like every interview, it will have a question. What is the difference between standard switch and DvSwitch? Okay, standard switch is host level switch. Possibility, human errors in network configuration. And here it's a vCenter level switch. We can avoid human errors and achieve compliance and reduce time to configure networks. Two things. And DvSwitch comes with new features called port mirroring, net flow, VLAN will support. Advanced features only available in DvS. Okay, 3 differences you have to remember. First one, second, third. It's a vCenter level switch. We can avoid human errors in configuration and we can configure the networks very quickly compared to standard switch. And there are advanced features with respect to DvSwitch which are not applicable with the standard switch. Okay, and assignment for you, find out about what is port mirroring, what is net flow, what is VLAN. Okay, in day-to-day job you will not be working with them, but interview sometimes if you just say what is these are the advanced features available only in DvSwitch and not available in standard switch. Most of the interviewers will stop here itself, but few guys will ask definitely what is net flow then. Okay, what is PV LAN, okay, kind of thing. So just try to find what are they mean. So by as of now we know some networking basics, virtual switch, standard switch. So you can understand these features if you read them. Okay, you can understand what they are meant for. And if someone gets any questions from these three topics, then we can discuss tomorrow. Okay, I'll clear them. But these two and these three total 5 points are very important for any interview and be aware. And to create a DvSwitch, you'll not get chance to create a DvSwitch frequently. It will be once in a while only. PC, go to network view. On the data center, right click on it, new distributed switch. Select compatibility. We'll see. Select uplinks, how many uplinks you want. Enter name. Select cluster. You can just click on OK. It will be created. Create a DV port group. After that, right click, vCenter, network view, DvSwitch. Right click on it, new DV port group, name and VLAN. Just say OK. It will be created and visible to all the hosts exactly the same way. Add or remove host from a DvSwitch. These are the lab tasks for a DvSwitch. VC, network view, DvSwitch. Right click on it, add or manage cluster or host. Select cluster, select host, map NIC with uplinks, migrate networks if needed, else you can skip. Migrate from standard switch to DvSwitch. That also is possible. And after this, just assignment or note for you. Migrate from standard switch to DvSwitch. Networks. These are the things for lab. So vCenter is down. Without vCenter, we cannot manage the DvSwitch. That's what we discussed just before. Okay, so DvS. Okay. So these are the steps you have to try with the DvSwitch and all. And this one also the lab test that you need to do. How you need to learn how to migrate networks from standard switch to DvSwitch also. This lab we will discuss tomorrow. Until then, you try, because vCenter is not available. If vCenter is not available, we cannot practice anything with respect to DvSwitch. It's a vCenter level feature. Okay. If VC is not available, we can't. But if it is already configured, No impact to the host and VMs. It will be continue to function. So that's where we discuss here. Okay, so DvSwitch management will not work if vCenter is not available, but no impact to the host and VM network functionality. They will continue to function as it is. Okay, but we cannot create new DV port group, add host, add and remove host. So it's not possible from the DvSwitch. So any question? Fine. Then we'll continue tomorrow.